Herbert Ellis Robbins was one of the most prominent American mathematicians and statisticians of the 20th century. He did research in topology, measure theory, statistics, and a variety of other fields. He was the co-author, with Richard Courant, of What is Mathematics, a popularization that is still in print. The Robbins lemma, used in empirical Bayes methods, is named after him. Robbins' algebras are named after him because of a conjecture that he posed concerning Boolean algebras. The Robbins theorem, in graph theory, is also named after him, as is the Whitney-Robbins synthesis, a tool he introduced to prove this theorem. The well-known unsolved problem of minimizing in sequential selection the expected rank of the selected item under full information, sometimes referred to as the fourth secretary problem, also bears his name. Robbins a problem. Biography. Robbins was born in Newcastle, Pennsylvania. As an undergraduate, Robbins attended Harvard University, where Mast and Morse influenced him to become interested in mathematics. Robbins received a doctorate from Harvard in 1938 under the supervision of Hassler Whitney and was an instructor at New York University from 1939 to 1941. After World War II, Robbins taught at the University of North Carolina at Chapel Hill from 1946 to 1952, where he was one of the original members of the Department of Mathematical Statistics, then spent a year at the Institute for Advanced Study. In 1953, he became a professor of mathematical statistics at Columbia University. He retired from full-time activity at Columbia in 1985 and was then a professor at Rutgers University until his retirement in 1997. He has 567 descendants listed at the Mathematics Genealogy Project. In 1955, Robbins introduced empirical Bayes methods at the Third Berkeley Symposium on Mathematical Statistics and Probability. Robbins was also one of the inventors of the first stochastic approximation algorithm, the Robbins-Monroe method, and worked on the theory of power 1 tests and optimal stopping. In 1985, in the paper, Asymptotically Efficient Adaptive Allocation Rules, with T.L. Lye, he constructed uniformly convergent population selection policies for the multi-armed bandit problem that possess the fastest rate of convergence to the population with highest mean. For the case that the population reward distributions are the one-parameter exponential family, these policies were simplified in the 1995 paper, Sequential Choice from Several Populations, with M. Kate Harkus. He was a member of the National Academy of Sciences and the American Academy of Arts and Sciences and was past president of the Institute of Mathematical Statistics. Selected writings. Books by Herbert Robbins. What is Mathematics? An Elementary Approach to Ideas and Methods, with Richard Courant, London. Oxford University Press, 1941. Great Expectations. The Theory of Optimal Stopping, with Y. S. Chow and David Siegmund, Boston. Houghton Mifflin, 1971. Introduction to Statistics, with John Van Ryseen, Science Research Associates, 1975. Articles. A Theorem on Graphs with an Application to a Problem on Traffic Control, American Mathematical Monthly, Volume 46, pp. 281 to 283. The Central Limit Theorem for Dependent Random Variables, with Vasily Höfting, Duke Mathematical Journal, Volume 15, pp. 773 to 780. A Stochastic Approximation Method, with Sutton Monroe, Annals of Mathematical Statistics, Volume 22, No. 3, pp. 400 to 407. Some Aspects of the Sequential Design of Experiments, in Bulletin of the American Mathematical Society, Volume 58, 1952. Two-stage procedures for estimating the difference between means, with Goya, S.G., Biometrica, 41, 146 to 152, 1954. The strong law of large numbers when the first moment does not exist, with C. Derman, in the Proceedings of the National Academy of Sciences of the United States of America, Volume 41, 1955. An empirical Bayes approach to statistics, in Proceedings of the Third Berkeley Symposium on Mathematical Statistics and Probability, Jersey Neyman, ed., Volume 1, Berkeley, California, University of California Press, 1956, pp. 157 to 163. On the asymptotic theory of fixed-width sequential confidence intervals for the mean, with Chow, Y.S., The Annals of Mathematical Statistics, 36. 457 to 462, 1965. Statistical methods related to the law of the iterated logarithm. The Annals of Mathematical Statistics, 41, 1397 to 1409, 1970. Optimal stopping. The American Mathematical Monthly, 77, 333 to 343, 1970. A convergence theorem for non-negative almost supermartingales and some applications, with David Siegmund. Optimizing methods in statistics. 233 to 257, 1971. Sequential tests involving two populations, with David Siegmund, Journal of the American Statistical Association, 132-139, 1974. A class of dependent random variables and their maximas, with Lie, T.L., Probability Theory and Related Fields, 42, 89 to 111, 1978. Asymptotically efficient adaptive allocation rules with T.L. Lie, in Advances in Applied Mathematics, Volume 6, 1985. Sequential choice from several populations with M. N. Kate Harkus, in the Proceedings of the National Academy of Sciences of the United States of America, Volume 92, 1995.